All right, so this is chapter 4 on earthquakes. This is just kind of the basics of faults and earthquakes. So, an earthquake is, the earth is shaking, right? We all kind of know that about earthquakes. And so, what's really happening there is it's a release of built up stress in the lithosphere. We're going to talk about that more on the next slide. Let me put this on. There we go, presentation mode. Earthquakes occur along faults. A fault is a break in rock where there has been displacement or movement from one side of that break to the other side. If there hasn't been any displacement or movement, it is just called a joint. It is not called a fault until it actually moves. Creep is just a really, really slow movement along a fault line. And fault displacement without any significant earthquake activity. It's just so slow. It's just kind of constantly moving. So it's not really like shaking anything. They call that the aseismic slip because there's no seismic activity associated with creep. So here's a diagram that really shows this well. This is the elastic rebound theory. And so this is essentially, if you get like a plastic ruler and you bend that plastic ruler, it's going to fold and bend and bend and bend and bend until a point where all of a sudden it snaps. That is the break. Then you have the fault. And once it snaps, all that energy of the ruler wanting to straighten out when it was forced to bend, it straightens back out on both sides of that break in the ruler. So you can see here that it was bent. Break happens, it goes back to being straight on both sides. And as that happens, you can imagine the ruler is going to vibrate back and forth really, really quickly for a while. And that vibration is the seismic energy within the crust, and that's what causes the earthquake. It's that vibration after the snap. Snap happens because the tectonic forces are bending and moving the rock until it just gives way. So why doesn't it just give way at first? Well, because it has a little bit of elastic properties where it can bend to some degree. And the deeper you go, the warmer it is. It can bend a little bit more than it can right up on top. But that elastic property allows it to give just enough bend for a while until there's so much stress, it overrides the elastic property. If you already have a fault, it's already broken, the stresses are still there pushing. You can either get creep, where it just slowly creeps along. The famous San Andreas in California, some sections of the San Andreas Fault are creeping, and they just kind of are slowly, slowly moving. Other sections are not. This is why they're so afraid of the big one there, is because you can imagine they're afraid that where it's not creeping, when north and south are creeping along, moving, and you get this section where it's kind of stuck, you can imagine the fear that one day it's going to unstuck or release and have that major earthquake. And so what's preventing it from slipping where it's stuck, that's where the bend is one, the angle in that fault. So if you imagine it's not really like this, it kind of bends. And so it's creeping up here and it's creeping down there. And I wish this would let me draw. I don't know if it, see if I do this. Let's see, just draw. Okay, so there's this bend in that fault. Okay, so up here it's moving, here it's moving, and right here, because of the change in geometry, it's kind of stuck. So that can happen, as well as just friction between the two sides. So it's not really smooth. You have pieces that are jutting out. So you have friction there. Water plays a difference too. Sometimes water can lubricate the fault, and if you have a lot of water, which is groundwater in the system right there, it can creep a little bit better, and if it's dry, it won't. So I think that is it for this slide. So let's continue on. All right. So here are just some terms, a little bit of vocab. So the areas of the fault. So here we have the fault scarp. You'll get this in a dip slip fault, which we actually talk about on the next slide, but not a strike slip. Strike slips are vertical. Dip slip, either a normal or reverse fault, where one part moves up or down compared to the other side of the fault. This here is a normal fault. And so where this is moved down, it's left this exposed, and this little, they can be large, they can be small, but this, I don't know what to call a slope right here, that's a fault scarp. The fault trace is that break that you see on the surface. So this is the fault trace, but it's not really the fault line. This is the fault line or fault plane because it's three-dimensional. Here we have the epicenter that is directly above the major break. So if you're on the surface and you're right here, you're pretty much on the center. But it's not really the center because the center happens down in the crust or the lithosphere somewhere, which is what we call the focus. Okay. This is the dip slip. So we measure these by our strike and dip. We don't only measure faults with strike and dip. We do this with bedding planes as well. So the strike is the orientation of this fault. So if I go back, this here, if I assume that like north is like up here, north, south, east. So this fault would have a strike of, I don't know, maybe 30 degrees northeast. It's kind of trending that way. This one, kind of trending this way, would have a strike of maybe 45 degrees northwest. And then the dip is how much it's dipping. So again, if we look here from the surface down, that might be just a perfectly drawn 45-degree angle. That would be a 45-degree dip. This next one here, that might be about 45 degrees too, dipping, but obviously in a different direction. So this would be dipping more towards the southwest, where the last one was dipping more towards the east. And so that way we can map them, predict them. If we can see the fault trace and the scarp at surface and we can measure that strike and dip, then we can extrapolate that, okay, where does this fault go? Does it go under any major cities or highways or anything? Type of faults. All right, so we have the strike slip fault. That is the San Andreas. That is where one side moves past the other. It's your transform boundary. And then we have the dip slip fault. So we have the normal, which is where the block above the fault moves down, and it's because it's being pulled apart. So this block, if the arrows were going the other way and being pulled apart, this is going to fall down. That is a normal fault. Reverse fault is the opposite. So the fault plane doesn't necessarily need to change. The forces are different. So reverse faults happen when you squish it together, and you can just imagine if you had some like triangular like wooden blocks that like little kids play with, and you squish them together, one's going to go over the top. And so then the top one comes up compared to the bottom one. This is actually called the hanging and footwall, not the top and bottom, but that's not mentioned here. So the hanging wall would go over the footwall. The thrust fault is the same thing as reverse fault, but with a very shallow dipping plane. So, if the plane is like almost what's drawn here, really, but maybe a little bit more shallow, then it's a thrust fault. Because it's got a really shallow dip, thrust material, when it's overthrown on that footwall, it can really go quite a distance and just completely like come over and lie on top. And then you can get like the same beds just completely repeating. You don't see so much overthrow like that with reverse faults, which have a steeper dip. All right, where are earthquakes? Again, much like volcanoes, mostly along the plate boundaries, but not always. We do have some within the plates, like our New Madrid fault, something Madrid, out here right by the Mississippi. It's actually very dangerous. And then the depths can be anywhere from shallow to deep. The deepest earthquakes happen in that subduction zone because you have that motion of that hard oceanic plate going so deep within the mantle there. And that is it for our introduction. Then we will move into seismic waves.